Welcome everyone once again to geometry. We're going to finish up section 2 with this third video. We've already talked about lines and angles, the title of section 2, but we'd like to finish up with a discussion on parallel lines. And before we do that, it seems that I missed a notation in the previous video. So we talked about perpendicular lines in the last video. Two lines, L and M, are perpendicular if and only if they intersect at right angles. And we can add some notation to that. So notation, if L and M are perpendicular, we can denote that by having an upside down T between them. So this is a little bit exaggerated, but that's approximately what it should be looking like for the notation. Excellent. So we can move on to parallel lines. Two lines, L1 and L2, are called parallel, provided that they do not intersect. Now there might be more definitions, or you could dive in a little bit deeper depending on your understanding of geometry and the things that you've defined so far. But for now and for us, this is a perfectly sufficient definition. And we can also give a notation for parallel lines. So if two lines L1 and L2 are parallel to one another, they'll be separated by two vertical lines, two parallel vertical lines. Okay, so L1 is parallel to L2. In some cases, some texts, these two lines are slashes, so you might also see L1 is parallel to L2. So might be a pair of vertical lines, might be a pair of slashes. Both would indicate that the two lines are parallel, L1 and L2. Excellent. So that's how we handle lines. We can handle rays by just considering the lines that the ray or line segment lies within. If two rays or two segments are parallel, if the lines that they lie within are parallel themselves. Excellent. So when we have a pair of lines, say L and M, that may or may not be parallel, and we have a line that passes through both of them, T, like this, a large collection of angles are made, 8 in particular. So we have names for these things. L and M we leave alone, but then T, the line T, is called a transversal. Transversal. Excellent. And then we have names for many of these angles as well. So angles 1, 2, 7, and 8 are exterior angles, while the others are interior angles. That's easy enough. Angles 3 and 6 form a pair of alternating interior angles. Alternating interior angles. 3 and 6 do, as well as 4 and 5. Angles 1 and 5 are a pair of corresponding angles. So 1 and 5 are corresponding, 3 and 7 are corresponding, 2 and 6 are corresponding, and 4 and 8 are corresponding as well. So these are the ways that we can refer to angles when we have such a situation. Keep in mind that L and M are not necessarily parallel. When they are parallel, we have a bunch of further results, which result from things that we've already discussed about. Let's see here. forgetting names here. Lots of terms have been introduced. All right, so based on our results of having linear pairs and then vertical angles, when L and M are parallel, we have a lot of results about these alternating angles or alternating interior angles and corresponding angles and so forth. So we can discuss that a little bit further, and I'm sure that you are familiar with them. So keep that in mind when you're trying to determine angles. If L and M are parallel, then we have a whole collection of linear pairs. And we have, well, that would happen anyway, but then we would also have a large number of vertical angles, but I suppose that's true either way. So we'll talk about more results later on that. Okay, excellent. So angles, relationships around parallel lines. Oh, I guess this is the conversation now. I'm sorry about that. I knew we were talking about it, I just forgot when. All right, so in Euclidean geometry, if the two angles L and M are parallel, as in the figure above, then we have that alternate interior angles. So 4 and 5, for example, are congruent. And we have that corresponding angles, such as 2 and 6, are also congruent. And we have that interior angles on the same side of the transversal. Okay. Interior angles, such as 5 and 6, and 3 and 4, which are on the same side. Oh, I'm sorry, on the same side of the transversal. So not paired this way, paired this way. So angle 4 and 6 pairs on the same side of the transversal. 3 and 5, a pair of angles on the same side of the transversal. These are actually supplementary angles. Excellent. And that is about it for this section. Yeah, that's all that we have on parallel lines. So a very brief video for this last one. If you guys have any questions about the second section, lines and angles, feel free to let me know. Otherwise, I'll see you guys again soon.